So for this example, when we're graphing a polynomial, this polynomial is not already factored, so we're going to have to go ahead and factor it, but with this example, we can factor it without using any synthetic division. So we can just use the regular rules for factoring, which to start off with would be using the greatest common factor. So we can take out a negative 5x cubed, and then the other polynomial factors into x minus 4 times x minus 4, which is x minus 4 squared. So our zeros that we end up with would be 0 and 4. So we go ahead and plot those points. So we've got 0 and 4 on our x-axis. Then we can go ahead and find the multiplicity for each 0. So in this case, we've got 0 has a multiplicity of 3, so it crosses the x-axis, and 4 has a multiplicity of 2, so it touches the x-axis. Crosses when it's odd, touches when it's even. So the other thing we'd want to determine would be end behavior. So for our example here, the degree is 5, which is odd, and the leading coefficient is negative 5, which is negative. So if we wanted to know end behavior, that tells us it goes up on the left, and that it goes down on the right. So we can go ahead and complete our graph from here. The only other thing I might do is just plot some extra points. So particularly a lot of times we'll try to choose x values that are in between any zeros. So I want to choose a value in between 0 and 4. So let's say we try to plug in x is equal to 1. If we do that and plug it into your function, you should get that. If x is equal to 1, then y is equal to negative 45. So I might just rearrange the scale here. So let's say that every tick mark represents negative 10. And that'll allow us to actually plot the point 1, negative 45 on here, which would be right about here. Okay, so now we're going to start with our end behavior. So in this case, since it's up on the left, I'm going to start my graph as being up on the left. And so I want to go down to my first 0. So in this case, that would actually occur at the origin, at 0. So here I have to determine, do I cross through or do I bounce back in the other direction? So we look at our multiplicity. Our multiplicity is odd. It crosses through. So we want our graph to just cross through, which makes sense because we had found the ordered pair 1, negative 45. So we pretty much have to cross 0 in order to hit that point. So once we hit that, we have to turn back around because we have to go to the 0, 4. And then we look again at multiplicity. So multiplicity is even, so it touches. So that means I don't cross through at this point, but I'm going to turn around and go the other direction. And what we see is it should line up with the other end behavior that we had found, which is that it should go down on the right, which is what our graph actually does.